everyone, Mrs. Moore here with a 5th grade math lesson for you on rounding decimals. It's lesson 2.4. Rounding is something you've been working on for a few years now, but as a review, rounding is a technique where you find a close estimate of a number by finding which value a number is closer to, with special attention to a given place. So when you're rounding, these two rules kind of pop up. If the digit is less than 5, then you round down. And I've heard you guys say here at Divine Child, 4 or less, let it rest. And if the digit is 5 or more, you round up. And I've heard you guys say 5 or more, let it soar. So the available digits in our number system are 0, 1, 2, 3, and 4, 5, 6, 7, 8, 9. So if the digit next door is 4, 3, 2, 1, 0, 4 or less, then we let that number be. We don't change it, we don't round it up, we keep it the same. But if that number is 5, 6, 7, 8, or 9, 5 or more, then we let it soar and we round that number up to the next value. So I'm going to scoot down the page a little bit here, and we're going to look at this example here about the number 80 and 74 hundredths. So we're going to practice rounding it to two different place values. So the first one we're going to look at is when we pay attention to the whole number, which I really wish they would have called it what it is, the ones place. Okay? What I'm going to do is highlight the ones place in this number, which happens to be the 0. And I did that for a reason, because this 0 is either going to stay as a 0 or it's going to bump up to the next digit, which would be 1, depending on the value next door. So the value next door determines if this 0 rounds up or if it stays the same. So I'm going to look next door, and some people like to draw an arrow like that, so that they know exactly which digit is going to be affected. And then they consider the rules. If this digit is 4 or less, then they let that 0 alone. They let it rest. If that digit is 5 or more, which in this case it is, they let it soar, which means that 80 becomes 81, as you can see right there. I would like to show you kind of a more visual demonstration of that. So here is the number 80.7. You can see it is definitely closer to which number, 80 or 81, on this little number line I made. For sure, it's closer to 81. So this is just a visual for you. Rounding means evaluate which is the closest whole number in this case for 80.7. This is the closest whole number. So this is the rounded version of 80.7. Now, if I wanted to take that same number and round it to a different place, in this case the tenths place, I'm going to highlight the tenths place. Again, I do the same technique where I look to the number next door in order to make my decision. Does this number next door tell me to leave that 7 alone, or should I bump it up to the next digit's value, which would be an 8? 4 or less, let it rest. So leave that 7 alone. The answer would be 80.7. Okay, and again, I made a little, here, I'll cover up the old one so it doesn't confuse you. I made a little visual here where I put 80.7 and 80.8 right here. And if I just stretch out this number line, 80.74 would be about right there. Again, which value is it closest to? This one, for sure. So that shows you that the rounding method of 4 or less, that rule actually follows true when you look at it visually, is anything 4 or less, it is closer to this value, and anything 5 or more is actually closer to this value. So that's just a little demonstration Feel free to stop the video right now if you'd like and take these notes on your workbook page. We like to use our workbook as a note taker so that when you go down to the assignment, you can just zip right up to the top and have some tips on what to do. More important things that maybe we'd like to use as a resource, we place those in our notebook, but this is a good place to take some quick notes. Now, if I'm going down to work on the assignment now, I have a couple tips for you. And I demonstrated them when I worked on these examples. Highlight the digit that you're rounding to, and then only look at the digit next door. Only look at the digit to the right to help you decide. So back up here at this 80.74, I didn't even need to look at the 4 at all. The only number that I needed to consider is the 7, the one right next door. It could be 4.9999999, and none of that would matter. The only digit that matters is the one right next door. So it looks like numbers 1, 2, 3, and 4, they'd like us to practice rounding to multiple place values. To the whole numbers place, which we know the other name for that is the ones place, the tenths place, and the hundredths place. So I'm actually, since I want to do some highlighting, I think I might copy this number down a couple times so that I can highlight the place values that I intend to round for each addition. Okay, so this will be where I round to the ones place, this will be where I round to the tenths, and this is where I round to the hundredths. So when you are finding something that's almost equal to it, or nearly equivalent, you do like a wiggly equal sign and not a straight equal sign, because that means exactly equal or exactly the same. If you're rounding, it's not exactly the same. So you do this like squiggly equal sign to show that it's an estimate or it's close to it. All right, so let me go and highlight which place value I'm paying attention to in this number. Blake, shh. So here's the ones place, I'm gonna highlight it there. Here's the tenths place, I'm gonna hide that one there. And here's the hundredths place, I'm gonna highlight that there. And then when I'm rounding, remember I only pay attention to this digit next door to help me decide. Should that 8 stay an 8 or should the 8 go to 9? So this is a 2, so remember 4 or less, let it rest. So leave that 8 alone. All right, look at this one. Check the digit next door. Would that 3 cause the 2 to change? Nope, let it rest. So I copy down 8.2, let it be. Look at the digit next door in the hundredth spot now. That's a 5, so 5 or more, let it soar. So this 3 becomes the next highest digit, which would be a 4. All right, let's set this one up just like I did for number 1, where I'm going to consider the ones place, the tens place, the hundredths place. And I'm just going to copy down that number so that I can highlight the place value that I'm paying attention to for each part of the question here. And there's my wiggly equal signs. I'm going to highlight the ones place on the first row, the tenths place on the second, and the hundredths place on the third. Only pay attention to the digit next door. It's a 0, so nothing changes with that 5. Let's look here next door. That 9 will definitely change this digit to a 1. Look next door here. Will the 6 change that 9? It will, but hang on a second. 9 is the highest digit. What do I do when I get to 9? So if 9 becomes a 10 and I can't fit a 10 in that position, what do I do? Well, what do you do when you're adding and that happens? That's right, you keep the 0 and then you carry the 1 to the column next door. So that actually carries over into the tenths place, right? So we've got 15.10. So it's kind of like it bumped up and regrouped into the tenths place that time. I know these happen to be the same value because we know 0 at the back carries no value. And that's okay because it happened to round to that place value. Number 3 and 4, I'm going to have you maybe pause the video and then check your work after you're done. I'm just going to go ahead and keep going, but pause it and try it on your own before you take a peek at my answer, okay? All right, how did you do? You getting the hang of this? Where if you're rounding to the ones place, you're only going to get a value that has that place value. If you're rounding to the tenths place, you're gonna get a number that has that place value. If you're rounding to the hundredths place, you're going to get a value that has that place value inside of it. Okay, I'm gonna scooch down the page a little bit, and it looks like we just have some true false statements. 83 and 645 thousandths rounded to the nearest tenth. Okay, so let me pay attention to the tenths place. Rounded to the nearest tenth is 83 and 7/10. Let's check. So check that digit next door. And 4 or less means leave that 6 alone. So the rounded value of 83 and 645 thousandths is actually 83.6. So is that the same as that? Nope, that's not true. And then you can actually write down the correct answer next door to help support you if you come back to this page for studying later on. 34 and 899 thousandths rounded to the nearest whole number, which remember we like to mark up our page as best we can. That's another word for the ones place. Let's see. That 8 would cause this digit 4 to bump up 1, and so it would become 35. Is that what they said? Sure is. 9 and 96 thousandths rounded to the nearest hundredth. Let me go find the hundredth spot. Is 9.01. Let's check it out. So that 6 would bump that 9 up. Remember what happens when you have a 9? That's right, you have to regroup. So this 9 becomes a 10 in disguise, but it's regrouped into the tenths position, and that 0 stays in the hundredths position. So let's see, is that the same number? It has the same digits, but it's not the same number. This is 9.10, and this is 9.01. So that's not true. It's actually 9.1 or 9.10. You can drop that useless 0 on the back if you'd like. Which of these numbers equals 7.6 when rounded to the nearest tenth? Select all that apply. That means there might be more than one answer. So let me go highlight the tenths place on all of these numbers. Let's go round them. That 5 causes the 4 to bump up. This 3 makes that 6 stay the same. This 4 makes the 5 stay the same. This 8 makes the 5 bump up. And this 5 makes the 6 bump up. Which of these numbers equals 7.6 is what I'm seeking out when rounded to the nearest tenth? Nope. Oop. Yes. Nope. Yes. Nope. All right. So on page 24, you have some similar exercises where you practice the skill of rounding. And I hope today's lesson was helpful. Contact me with any further questions, all right? Have a good day, everyone.